In this training video, we're going to take a little tour of the point cloud module, but we are specifically going to focus on uses of the Supersonic Viewer and its ability to view LiDAR. Now, our starting point is a LiDAR file, a .las file that covers this pit, and this pit has been contoured by using the point cloud module and a feature that will produce a TIN file from a point cloud, which then can be contoured within the civil module of Carlson software. So to begin to illustrate the Supersonic Viewer, we're going to use that TIN that itself was made from a LiDAR file. And then we're going to show you the whole process of creating that TIN. A lot to go over here. Now, back to the Supersonic Viewer and its power. Supersonic Viewer is new since 2017, since the 2017 release of Carlson software. And it appears under the 3D viewer, and it's in addition to the viewing of drawings and viewing of TIN and grid files with the surface file option. It is a faster viewer, and hence its name, for viewing TIN files. Let's prove this. Let's go to the surface file viewer, which has been in the software for well over a decade. We're going to view extract2.tin, a 30 megabyte TIN file, the very TIN file that came from an original point cloud using the point cloud module. Let's view this 30 megabyte file. Let's open it. And you can see there's a delay even in the dialog appearing with all the prompts that come up, all the options. It takes a few seconds, given the sheer size of this TIN file. We're just trying to view it. And when it comes in, you'll see that it looks good. It looks like this pit. But as a user, you'll detect a little hesitancy in terms of the viewing of the file using tools like spinning it, zooming in and out with the mouse wheel. We have by default color by elevation on. If that is on in the previous use of this command, it's on by default when you use it again. If that's clicked off and then on, it takes on this file about 10 seconds for the file to color out. So we will just exit and view this in the Supersonic Viewer. Strictly a viewer. The Supersonic Viewer is strictly a viewer. Now we've hit the exit button. There's a little delay even in exiting, but now watch for the speed factor of the Supersonic Viewer. We're going to click that. It has a different interface, but we're going to load a surface. Go right to this option at the top of the screen and load. We'll load that same 30 megabyte file and hit open. Very quickly, you see the file in plan view initially, and then you can spin it and look in on it. Now, if you look at the view settings near the bottom of the screen, you can see that its default is colors and textures, and the style is defaulting to CAD colors. Now, the CAD colors have an interesting built-in aspect that any relatively flat surface appears with a greenish texture, and the steeper surfaces have a gray to purple texture, which has a nice effect of indicating a more rocky slope versus a flatter, perhaps grassed slope. So immediately using this option of CAD colors, you see a very nice contrast, if you will, of steep surfaces and more gradual surfaces. And the performance is extremely fast in terms of using the mouse, scrolling in and out, or perhaps switching mode. Here's the view by elevation. When I switch that mode, it's virtually instantaneous. And you can see the colors distinguished here by elevation. And then we can simply go back, scroll down, and go back to the viewing of it by CAD colors. Another option is by survey, but it's all one color in that case. Still a distinguishing of the steeper slopes, but there's such a better contrast in the Supersonic Viewer that it would be hard to argue which viewer reveals the site most clearly. It would be Supersonic Viewer, clear and fast. Now, let's contrast this. Let's go ahead and get out and re-enter it. If we enter the Supersonic Viewer, one of its distinguishing features is you can view LiDAR. And this is, in a sense, free with Carlson Survey, free with Carlson Civil or Carlson Hydrology, any of the modules of the Carlson Office programs, which are represented by these various icons in that toolbar. So let's go ahead and view that same site from the standpoint of the source data, which is the LAS file. This LAS file consists of 19 million points. So instead of clicking on Load Surface, we click on Point Cloud. And we load the cloud here, which is an LAS LiDAR file. And here you're getting, in a sense, viewing of the source data. Now, it comes in default in a single color. What you do then is go down to the View Settings and set it to elevation, for example. And immediately things start to pop and contrast more as the elevations of the point cloud nodes or dots are colored by elevation. But if the file includes colors or RGB values as part of the LAS file, you can select Style Survey. It's the original survey or measured result. And then you have the RGB values of the LiDAR data appearing. So any field that truly is green appears green by this method. Gray areas that are stony or rock piles have that look. And you actually get a sense of the natural colors of the LiDAR file itself. This is a pit. It becomes very clear what's going on there using the point cloud module and its ability, using the Supersonic Viewer and its ability to view a point cloud. It comes free with all modules of Carlson. So with that, let's go ahead and leave the routine and provide a little more perspective on features of point cloud module in contrast to the viewer-only features of Supersonic Viewer. That same point cloud can be viewed efficiently with the point cloud module of Carlson software. If we click the point cloud module icon and load the module, we can make a new file or open one we already have for this site, Pit 1, and we can double click and view the surface with the color aspect on. Let's minimize that and illustrate how even that was created. We can right click and create a view, and then we have these options on how we view it. So one is to view the actual native color of the drawing as opposed to color by elevation. And if we click OK, here's that same view we saw over in Supersonic Viewer as seen within the point cloud module. The point cloud module has an equivalent viewing speed, so we can get in close and study that site in some detail. Now, the point cloud module can also create a tin from a point cloud, and let's illustrate the process. Let me also point out that this button here will perfectly tile this window to fit to the right of the dialog. I can move over and get to the right of our tree where we conduct options within the point cloud module. But if we click this icon in the upper left, it tiles whatever we're viewing perfectly in the remaining space to the right. Now, what we're going to do is take this cloud that we've loaded, and we should point out, how was the cloud loaded? You right-click and import from LiDAR, from an LAS file. And so when that is done, I could import any LAS file in this list and view it. Here's a completely different one that we can load. And that can become part of, we can convert it metric to US feet, US feet to metric. Many LiDAR files are default metric, so you can convert them on the fly to US feet or do no conversion at all. And this is the process of bringing in additional cloud data. That's how the two that you see, metric and converted to feet with color, were brought in. So now I have another one which can be viewed. Ideally, you would minimize this view and go ahead and view the additional one here, color direct. And this one's not quite as interesting and probably doesn't have RGB values. We'll go ahead and exit it, but that is the process of bringing in clouds. Right-clicking in the tree that appears and doing an import of LiDAR or other sources of data. But if we have a particular cloud that's been brought in, perhaps converted on the fly to feet from default metric, then if you right-click that cloud, you can create a tin mesh. So if we click on that, you can control how many mesh vertices you will allow. And the program will find the most important vertices to create an accurate mesh up to the limit tolerance you've set. So we'll go ahead and set for a 500,000 mesh size, click OK. Then the program will go through a process of cleaning the cloud and creating that 500 vertice mesh, even though the cloud itself contains, the LiDAR file contains 19 million points. This created mesh 2, which then we can study in terms of the property or view. But then this internal mesh or tin mesh to the point cloud module can be exported to a Carlson tin. We click on export tin and we'll call it, it's a 500K, we'll call it extract 2. And this is the second version of it that we've made. And that is the very tin file that we began our work with, viewing in both the 3D viewer, the surface viewer, and the Supersonic Viewer. So Supersonic Viewer, strictly a viewer, not only of tins, but of LiDAR files, of point cloud files. And the point cloud module is a way to similarly view point cloud and LiDAR files, but its use is to extract features as well as create tins that can be downsized for usability within the Carlson program. So now let's illustrate one of those usability aspects. Let's hit exit here. We'll go ahead and save our changes and go ahead and use a command under the civil module called contour from tin file. We just made a tin file that will contour at 2 and 10, and we're going to use extract 2. And we've clicked on in that previous dialog to an option to minimize meandering, because point clouds will tend to create a lot of squiggles, if I can use that word, and we've minimized those to the best we can with an option. And we've also said don't plot any contour that its total dimension is less than 5 feet. So very small dot-like contours will not clutter our screen. So now the program is going through the process of contouring. These contours are now drawn, as you can see here, and the benches can actually be detected using the command quick profile. We can come in and reference the surface file and be sure we pick the correct one, 500K extract 2, and then we hit OK, and we'll just pick a line across the pit, hit enter, and you can see the benches are detected even though the data came from a point cloud that had 19 million points and didn't pick up every single breakpoint that it could along all these benches. You can zoom in on the line that was drawn, and because we're coming from a surface, you can do the command adjust alignment, grip in the middle there, and watch it change real time as you move the alignment up and down. You can see the benches left and right. Now we'll go ahead and exit this profile or draw it. Let's adjust alignment and move it into position here. Go ahead and draw. And we're going to go 50 and 50. And we'll place it over to the right. And you can see there's a bench-based profile coming from a tin extracted from a point cloud LAS file from within the point cloud module. So the tin is accurate enough to reveal the benches using that feature to create a tin of user-specified number of tin vertices. So that was a tour of use of the Supersonic Viewer as well as the point cloud module with respect to LiDAR files and how to make tins from LiDAR files.